Hello, I'm Mr. Rast, and this is the fifth lesson I'm giving in the topic of data analysis. In this one, we're going to actually put everything that we've been doing, rearranging equations, dimensional analysis. I don't know so much dimensional analysis in this one, but rearranging equations, using significant figures properly, scientific notation, making sure our units are in there. This has all come together with some real calculations, some real things that we're going to be doing. Now, when we do this, we're going to be dealing with primarily density in this one here. And with density has properties that I need you to understand the difference between the properties of intensive versus extensive properties. An intensive property is a physical property that does not depend on the amount of a substance. Density is an intensive property of a substance, whereas an extensive property is a physical property that is dependent on the amount of the substance. And it does seem to be a little confusing if you look at those definitions and stop to think about it a little bit. It's easy to just let it blow by and don't catch the concept of what's going on here. I will ask you on tests and quizzes if certain properties are intensive or extensive. And my advice to you is to think of it like this. Would dividing the substance change the value of the property? If the answer is yes, it's extensive, and the answer is no, it's intensive. Perhaps I'll give you some examples here. So let's look. Would dividing the substance change the value of the property? Would dividing the mass, if dividing the substance's mass, if we divide a substance, would that change the mass of the substance? If it's yes, it's extensive. If it's no, it's intensive. So certainly if you took something and divided the substance, then the mass would change. And if it would change, it's extensive. The density, a lot of people think at first it's intensive, but it's not. If you take the density of, if you take something and separate it, the substance, the density isn't going to change. The density is the mass divided by the volume. And if you divide it, then you're cutting, say you cut it in half, then you're cutting the mass in half, but you're also cutting the volume in half. And we'll get into those kind of calculations later. But regardless, gold is dense. It doesn't matter if you have a big piece of gold or a little piece of gold, the density of the gold isn't changing. Whereas color, or not whereas, but color, let's try to think about that one. If you have a substance like gold, a piece of gold, and you divide that substance, you have a little piece of gold. Does the color change? No. Then that's intensive, just like the density doesn't change when you cut it in half. If I take a piece of gold and cut it in half, would the volume of that gold change? Yeah, that's extensive. Would the viscosity change of a substance if I cut it in half? Viscosity is how a fluid flows. So like syrup is very viscous. If I had less syrup, would it be less viscous or more viscous? No. Therefore, it's intensive. Would the length change if I took the sample and cut it in half? Yeah, it would. So that's extensive. The way I think about these, because these words look so similar to each other, is if dividing it in half does not change anything. I think of dividing it. Let's think if we're trying to distract the property of it. Think of someone that's very focused, someone that's very intense, an intense person. If you were to try to distract them, if you tried to divide stuff around them, and it doesn't change their focus, they're very intense. It's intensive. Nothing's changing it. Where extensive means something externally will change that value. So something externally can change the mass. So I can externally divide it, then the mass changes. So you got to keep these straight. However you want to think of it is up to you, but that's just the trick that I use to think of the difference between extensive and intensive. Now, like I was saying, this is going to be using these things that we've learned with the real calculations. We're going to start with an easy one, density. You've probably done density problems before. And that is the mass of a substance per its volume. So the density is the mass divided by its volume. It's represented with a capital D, and mass is a lowercase m, and volume is a capital V. People often use, they don't use the word density, and they often consider things to be light or heavy when they really mean dense or not as dense. For instance, you could have the same volume of something, two cubes, and if one of them was gold and the other one was aluminum, the gold one would be much heavier for the same volume. It's much heavier. It's denser. But a lot of people will grab this. They'll grab something and they'll go, "Whoa, that's very heavy," but it's not as heavy as I am. It's just a little, a little block of gold. So heavy is all relative. The proper way to say it would be this is very dense. It's much more massive than I expected for its volume is the truth behind it. When we do our density problems, I'm going to throw in, and especially because we're going to be doing a lab with density, I'm going to throw in percent error. Our percent error calculation is calculated like this. So we're going to do this a lot in this class. It's calculated as the percent error equals the experimental value minus the accepted value. Experimental is what you got in lab, what you actually did, minus what you should have got, the accepted value. These vertical lines mean absolute, the absolute value. So the experimental minus the accepted, and don't make it a negative, it's the absolute value. So really, it's just the difference. It's the difference between what you got and what you should have got. And I want the absolute value, no negatives. Divide that by what you should have got. That's the accepted value. And then multiply it by 100. This is the percent away from the accepted value. So let's think about it. If I did it perfectly, let's say it was supposed to be 100, and I did my lab and I got 100, and so I do 100 minus 100 because that's what the accepted value was also. That would be 0. 0 divided by 100 times 100. Anything 0 divided by anything is 0. So therefore I'd have a 0% error. If your experiment is the same as your accepted, it'll be a 0% error. And that's good. You don't want to be far away. Let's do a practice problem here. If the accepted density of a substance is 1.59 grams per milliliter, and the student's experimental value was 1.54 grams per milliliter, what is the student's percent error? If you want to pause the video right now and give it a shot, I would suggest working ahead is a good idea as a study tactic. All right, hopefully you gave it a shot, and let's see. The first thing is, what do you know? You know the density of the accepted value. The density of the accepted value is 1.59 grams per milliliter. We know the density of the experimental, that's what the student actually did, is 1.54 grams per milliliter. Our formula is the percent error is the density of the experiment minus the density that's accepted divided by the accepted density times 100. We put those values in there. So we put our experimental value, 1.54 grams per milliliter minus 1.59 grams per milliliter, and I take the absolute value of that, which would be 0.05 grams per milliliter, and then I'm going to divide that 1.59 and multiply it by 100. Do yourself a favor and do me a favor and get a calculator and actually try this. And if you did, hopefully you got 3.14%. Remember, the question has 3 significant figures in this number, 3 significant figures in this number. You use the weakest measurement to answer questions in it. So I'm going to use the weakest measurement of these two. Well, they're both 3, so it doesn't matter. And so I'm going to answer in 3. If I answered in more than 3, I am telling the reader that this was a very precise experiment. And it wasn't. It was just 3. This table is going to be used for the practice problems we're about to do. Students in my class, this is printed out and I handed this out to you guys. It should be in your notebooks right now. And if you want, I'll put a link to this on my website and you can just print it out at home. Or you can use this video and just go back and forth, look at this, and then go look at the questions. Because sometimes you might be solving for an unknown and you'll need to go over here. I'll say, what is the copper's density, and you'll have to use this paper to look it up. So using tables and looking up things is something chemists do quite often. So I wanted you guys to get used to that. So here's our 5th coursework. This is the last coursework before our data analysis exam. You should practice all 5 courseworks when I write my tests. I look at these courseworks, I see how I worded it, I look at the practice problems we did, and I hold you accountable for what we've gone over in class. Your best study guide is to study these classworks and study the examples that I give you. So in this classwork, notice in the first one, what would be the mass of 2.5 liters of helium gas? So in this one here, our density problems, what would be the mass? I'm solving for the mass, and I didn't write that. I have density equals mass over volume. So you're going to have to rearrange the equation for mass. If you're not comfortable or you forgot how to rearrange equations, I highly suggest you go back to classwork 1.1 where we practice rearranging equations. Also pay attention that this is 2.5 liters. And these units are grams per milliliter. If you show your work in your calculations, which you have to do in my class, you'll notice that milliliter and liters are not the same, and these units won't cancel out. So you got to be careful. Don't think things are too easy and blow through stuff and make a lot of silly mistakes. Be careful. Look at the units. Look at the units here. Figure out that you're, solving for mass. Make sure you rearrange the equations properly. So be careful. There's a lot of, a key to being a good scientist is paying attention to detail. So give this a shot and let me know how you do. And if you have any questions, let me know. I'm here to help. Thank you.